Hello students, last class we couldn't introduce ourselves and my name is Ampadi, a Keralite from India, and I have taken my post-graduation from Kerala University. And last class we have some assignments including what's alchemy. In medieval period, all the chemistry is concentrated to transmutate all the base metals into gold. It's a fantastic imagination. If we can change all the periodic elements into gold, that's a special day for women, because 1 gram gold values $60 approximate and 4,000 rupees Indian rupees approximately. And did the imagination work? Yes, the imagination really worked. We could change some of the metals into gold, but it's not commercially and economically. But yesterday it was an imagination, but today it's a reality. So our great teacher and the Indian missile man, Dr. APJ Abdul Kalam, said to the student to dream beyond beyond the horizon, because tomorrow your dream will be a reality. So the second part of alchemy was in search of an elixir, but it's still an imagination. So students, dream yourself, because your dream will be a reality tomorrow. And last class we came across the concentration terms of solutions, and there are different concentration terms because it has very importance for its practical application. So today we are considering some of the terms in molarity. So we are taking the concentration term molarity. So from definition, you know that molarity is the number of moles per volume of solution. Volume of solution. And there a term comes, words mole. It's a count, just like you are taking a dozen, 12, and a score of 20, a gross of 144. You can consider a mole is equal to 6.022 into 10 to the power 23. And from where this number came? 6.022 into 10 to the power 23. In Newtonian world, you know that we can count all the things, all the micromolecules, because they are visible and they are material. But if we came to micro world, all the subatomic particles, electron, proton and molecules, atoms, they are invisible and we cannot count it all. So scientists thought that if we can relate the count to the weight, then we can relate the weight and count, then it is very convenient to calculate all the problems. So they take carbon 12 as the base atom. You know that why carbon 12 is taken, because 1 atomic mass unit, and thereby the weight of all the elements are related to carbon 12 atom, because carbon 12 is the most stable isotope of carbon. So 1 atomic mass unit is 1 by 12 the mass of carbon 12 atom. So we are taking carbon 12 atom and 12 gram of carbon 12 atom. 12 gram of carbon 12 atom. We take 12 gram of carbon 12 atom, that equals 1 gram atom of carbon 1 gram atom of carbon. Then what happens is that they are dividing this 12 gram by the gram of one atom, that's approximately 1.99 into 10 to the power minus 23, and they are getting an exact number of 6.022 into 10 to the power 23. That means you are dividing the mass of 1 gram atom then by one atom of carbon 12 atom, you are getting 6.022 into 10 to the power 23, and the scientist taken it as 1 mole, and thereby we can relate the mass of all the elements into mole, number of moles. So what about the weight of hydrogen atom? Weight of hydrogen atom is equal to 1 atomic mass unit, and it equals 1 by 12th the atomic mass unit of carbon 12 atom. Then if 1 mole of carbon 12 atom is 12 gram, then 1 mole of hydrogen atom equals 1 gram. 1 mole of hydrogen atom equals 1 gram. We can write it as 1 mole equals 12 gram of carbon 12 atom. 1 mole equals 1 gram of hydrogen atom. That means how much it is to the weight of the carbon 12 atom. Then 1 mole equals 16 gram of oxygen atom, because oxygen is 4 by 3rd the weight of what? Carbon 12 atom. 1 by 12 the weight, therefore 1 mole contains only 1 gram of hydrogen atom and 1 mole contains 12 gram of carbon atom. Then this 12 gram of carbon atom is equal to 1 gram atom. 1 gram atom. This is also 1 gram atom. This also 1 gram atom. And we can say that 1 gram atom contains 1 mole. 1 gram atom of every element contains 1 mole. Okay. Then mole equals, how can you find the number of moles? If you are taking 24 gram of carbon 12 atom, then 24 divided by 12 equals 2 moles. It contains 2 moles. How you get it? It's you are dividing the given mass with the mass of 1 mole. You are getting the number of moles. Okay, then what's the number of moles? It's the given mass divided by mass of 1 mole. Mass of 1 mole equals number of moles. Okay. Then molarity equals number of moles per volume. And what about the volume? Volume is always in liter, and 1 liter equals 1 decimeter cube. We can write it as 1 liter equals 1 decimeter cube. 1 decimeter cube. And what about the molar volume? Molar volume. Then the molar mass you are getting it as 1 gram atom. And what about the molar volume? It's the volume contain 1 mole. And a study by an Italian scientist Amedeo Avogadro shows that equal volume contains equal number of molecules at a particular temperature and pressure, a constant temperature and pressure. That's known as at NTP, normal temperature and pressure. All the gases contains same number of molecules at equal volumes, and that is known as theory of equal volumes, and that is 1 molar volume is equal to 22.4 liters. That means 22.4 liters of every gas contains 1 mole. So we can say that molar volume of any gas is equal to 22.4 liters. 22.4 liters. And if mass and density are given, how can you calculate volume? Then volume is equal to mass upon density. Then we are getting volume, mass upon density. Then volume is equal to mass upon density. You can take the symbol as rho. It's equal to mass upon density. So these are the terms. Like universal gas equation, there is an equation of molarity also. For a solution, equation of molarity is equal to M1 V1 is equal to M2 V2. As the concentration changes, the volume also changes to undo the effect. That's another term, that's another theory, that's Le Chatelier's principle. According to this, the volume adjusts for adjusting the molarity. So that's another equation. That's equals M1 V1 is equal to M2 V2. M1 V1 is equal to M2 V2. So we are perfect for finding out molarity because we are getting number of moles, and if a complicated molecule is there, how can we calculate the molar mass? Mass of sulfuric acid contain 2 hydrogen atoms and 1 sulfur atom and 4 oxygen atoms. Then how can you find out the molar mass? Molar mass equals the mass of the individual atoms present in it. So hydrogen atom, 2 hydrogen atoms having 1.008 atomic mass unit, but we are rounding it off as 1 for the convenience of calculation, and plus 32 into 1 and plus oxygen atom 16 into 4, you are getting 2 plus 32, 64 equals 98. 98 as the molar mass of sulfuric acid. If a given mass is there, given mass for sulfuric acid is there, and if there is a molar mass is 98, you can find out the number of moles. And if volume is also present, directly dividing with the volume of the total solution, we are getting the molarity or the concentration of that solution. Here's a problem. How many milliliters of sulfuric acid of density 1.84 gram per milliliter, containing 95.6 mass, containing 95.6% mass, should be added to 1 liter added to 1 liter of 40 mass percentage, 40% mass, having density 1.31 gram per milliliter, 1.31 gram per milliliter. In order to prepare 50% solution, 50% sulfuric acid solution, having density 1.40 gram per milliliter. 3 solutions are there, gram per milliliter. 3 solutions are there, and one having a 95.6% solution. That means its concentration, mass concentration and density is given 1.84 gram per milliliter. And how many milliliter of these two concentration to be added to this concentration, added to 1 liter? Volume is 1 liter and density 1.31 gram per milliliter, to prepare a 50% solution of 1.40 gram per milliliter. 3 densities are there and 3 concentration terms are there. Therefore, 3 masses are there. What we can do here is we cannot use the molarity equation here. The terms we need to write here, where we can write here the given terms. We can write here the given terms. First, solution 1 of sulfuric acid equals the concentration equals 95.6%, density 1.84, and its volume is not given, so we need to find out. And for a second solution, S2, it's a 40% solution, concentration is equal to 40%, density equals 1.31 and volume is given 1000. That means 1 liter is equal to 1000. And for the solution 3, concentration equals 50%, concentration is 50% and density equals 1.40 gram per milliliter. These are the given things in this problem, and how we can match this. M1 V1 is equal to M2 V2. That's a molar concentration, but we don't get the molar volume. But if the mass of the first one plus mass of the second one gives mass of the third one, that's the thing we can take as an equation. So you know that mass is equal to volume into density. So for S1, mass is equal to, what about its volume? It's unknown. And what about its mass? It is volume into density. The percentage is 95.6 upon 100 into 1.84 into V. That is the mass of the first solution. And for S2, mass is equal to 40% solution into its density 1.31 into its volume is 1000, and for S3 mass equals 50% solution into density 1.40. But what about the volume of this one? What about the volume? It's the volume of the total volume B plus 1000. We can write it as B plus 1000. Then how can you equate this? M1 plus M2 gives M3, and by equating this one you are getting the volume as what it is, 166 approximate, that much milliliter. You calculate it yourself for the next day, and these are the problems we came through. So students, today there is one assignment for us, and the last class we came through the practical applications of this one, and today you do more and more problems with the molarity. All these are very easy compared to molarity, mass percentage, parts per million. All the things are very easy to calculate, and our today's assignment is about two scientists, and our first scientist is Canada, that's from India. That this is your work to Google through and to find out what he proposed, scientist Canada. And the second one we already stated as the theory of equal volumes. Volume of all the gases contains equal number of molecules, and that is put forward by an Italian scientist, Amedeo Avogadro. And you need to find out how he came to the conclusion of theory of equal volumes, and our second scientist is Amedeo Avogadro. Amedeo Avogadro. So students, we are coming with the assignments. Thank you.